Hey everyone, welcome back to stream 94 of building the flight booking engine. I just need to do the obvious check to make sure that the audio is okay, like always. Sometimes you start a stream and you think you're actually serving audio, but you're not. So let me just, okay. So all looks good. So let's start. So this is going to build on from the previous video. In the previous video or stream, that is day 93, I talked about the initial steps that we need to take to move to Kubernetes. So Kubernetes is going to be responsible for orchestrating our image, okay, or our backend. But I want us to progress in small steps so that even people who don't know what Kubernetes is, don't know what Docker is, can easily flow in. Yeah, but I know that people who have been following me from the very beginning are very, very good with this project and are able to make changes that they want. And by the way, if you want to learn Kubernetes from scratch, I have a playlist where I learn Kubernetes from the documentation. I plan to consolidate that into something better maybe in future. Marvelous. Good morning. Whether it's morning or evening or afternoon where you are. But thank you for joining. I hope you're doing great today. All right. So I want to explain to you the problem at hand. Okay. So I'll start with the problem that we have at hand, and then I will go to show you the solution. I think that's a better approach. The problem, then the solution. Okay. And I've touched on the entire idea. Okay? The whole major idea is to go to a Kubernetes platform. But in today's video, I want to explain to you something. Our main.py file was handling everything. Okay. And I'm going to show you that right now. I hope my audio is okay. Marvelous, please let me know if you can hear me clearly. So maybe I need to just create a new terminal. Why is it not expanding? Okay, I have access to it now. So I'll go into the backend directory, and I'm going to show you, because I've already made changes to the main.py, but I want to show you what the main.py was doing. So I'm going to undo some changes so that you see the problem and then the solution. So I will do git. First of all, go to the main.py, copy everything that is here. Okay. Actually, I can even just duplicate it. Okay. Since it's not, okay, it won't have to duplicate it. Then I just can say git restore main.py since I've not staged it. Thank you, Marvelous, for confirming. So when I go to main.py, okay, forget about this copy, main.py, look at this, okay? I'm going to explain something and you're going to see the challenge. In this main.py, of course, we have the security config. We have here the lifespan. Look at the lifespan, okay? We have, number one, database being initialized. We have the Kafka producer, okay? We have registration of the Kafka consumers, okay? This one on line 85 is the producer. If I said consumer, forgive me, it's the producer. So we have database being initialized. We have the Kafka producer, okay? We have the consumer registrations, okay? For the user events, booking events, payment events, ticket events, okay? We have the consumer being started, okay? Consumer being stopped and the producer being stopped. So look at the number of things which are being started. Okay, not started, but being done. The database okay, connection, the Kafka producer, consumer registration, consumer starting, okay, and consumer ending, and the producer also ending. Now, what does this ring a bell in your mind? It is simply telling you that this main.py file, or the process that FastAPI is going to be running on, okay, is handling HTTP requests, the database, okay. It is also handling things like giving the notification consumer the actual processes or functions that are going to process the events being produced by Kafka. Okay, I'll repeat. We have HTTP requests being handled. We have the producer that is responsible for acting as a Kafka producer. Then we have events being consumed. Okay, and we have the consumer itself being started and the consumer and producer being stopped. That is not a good thing. Why is it not a good thing? Because in production, okay, if we try to scale the API, if you scale the API, it will mean you are also scaling the consumer, okay? Because remember, this is going to be one image, okay? One Docker image. Once you scale it, okay, it means you're scaling within it, you're also scaling what? The consumers, which is a bad thing, okay? Guys, please let me know if you're understanding this. Okay, I want you to understand the problem first. Okay, before you go to a solution, it's always good to understand the problem. If you understand, please let me know. Okay, so I want to split it in such a way that we have one container, okay, responsible for HTTP and producing events, meaning we shall have an image responsible for starting FastAPI, and that image instance or container instance will be responsible for producing those events also. Okay, so handle HTTP, produce events. But I want another instance of the image or another container to be responsible for consuming those events. Why? So that in case we have so many events being produced, we can scale the consumer separately and scale the what is called the image for HTTP separately, or the container running FastAPI separately. That is the goal, okay? To scale separately and make it easier in production. So I will clean this up, okay? And maybe go back, okay? Can remove this, delete this one, okay? And then rename this to main.py and show you, okay, the changes. I'm going to explain to you everything. I'll not leave any stone untouched. So right here, if you look at lifespan instead, okay, now we only have initDB, okay, then we have the producer, okay, and then producer stop, producer start, producer stop. Look at this, it is clean. There is no notification consumer registration. There is no consumer starting. There is no consumer ending. Okay, everything concerning the consumer has been removed from here. Later we can go on to even improve this. Okay, but this is a good first step to achieving proper scalability. Okay, now how is this going to happen? Okay, where are the other things? Okay, I'm going to show you and explain to you in a bit. Now, in the previous video, I showed you how to deal with the Docker file successfully, okay? And we stripped Docker out of it. And later when we build an image, okay, we are going to use that image to start two processes. One process will be for the HTTP or the FastAPI app, and the second process will be for the Kafka consumer. Think of it as a worker which will be ready to listen for events. And that is demonstrated even for local development in compose.yaml. I will show you that right now. And that is what Kubernetes will also do. You get. So if you look at the FastAPI app here, okay, in the compose.yaml, we have an image called error bound local, okay? And it has, of course, the container name, okay? And it has a command, okay? For development, we simply do the same command, okay? Run FastAPI main.py --port, okay? And specify this host argument. We do the same command for local development, okay? Even in production, Kubernetes will target this, okay? Understand that. Kubernetes will target this separately. And also, Kubernetes will target a notification worker, okay? How will it do it? To simply say Python -m backend.worker. And you're going to see what backend.worker is. Again, I'll repeat. Using one image, okay, we shall run 2 containers, okay? We shall run 2 processes in Kubernetes, okay? I'll repeat. The first one will be using the same image called error backend, okay? And we run the command FastAPI run main.py. That is for the process handling HTTP. Then for consuming, we shall use the same image, but this time run Python -m backend.worker. That is a good first step. For now, you're still seeing Doppler because this compose file will be used for local development. As simple as that. So I'll close this and go on to explain to you the backend.worker. So what is backend.worker? Simply referring to this backend directory, then to a module called worker right here. Okay. And backend.worker is doing something very simple. Okay. It simply imports the consumers. Now, for you who has been here from the very beginning, you know the consumers, okay, and how they work. Okay. We spent about maybe 2 or 3 live streams explaining this. I don't have to go into this, okay, but simply not exports, but imports 2 functions to start the notification consumer and another function to stop the notification consumer, and of course imports a function to help us perform logging, and of course a sync IO and signal. And you're going to understand why we import them. Down here we have a function called run worker. Okay, run worker simply takes a shutdown event, which is of type async IO.event, which can be none. And by default, it is none. And this function returns nothing. It is a void function or returns none. Okay. Why can it be none? Because it can help us when you're testing. Okay. When you're testing, you may not need to depend on a real async IO event. You can mock one and pass it to this function. Okay. In order to do your tests. Now, let's move on. On line 14, we simply do what we're doing the other side. I just shifted the logic this side, okay? We get the current running loop using async IO dot get running loop, okay? That gives us the currently running loop, okay? And if the argument is none, meaning there's no argument passed here, okay? We create one, okay? And then say for every shutdown signal, okay? So right now we are looking at 2 shutdown signals. There's signal.sigterm and signal.sigint. SIGINT is the signal that is sent when you press Ctrl+C in your terminal, okay, to stop a process from running. In our case, it is the backend, our application, okay? So the signal will be signal.sigint. Then when Kubernetes or Docker sends a stop command or to kill our application, okay, the signal will be signal.sigterm. So on that event loop, we simply add signal handlers for the SIGTERM and SIGINT, which simply means when we either shut down or when Kubernetes itself decides to shut down. As simple as that. Then after that, we simply call the notification consumer and give it the event loop. Okay, so we are binding the event loop to the notification consumer log. Okay, then after that, we say await shutdown event.wait. Why? If we don't do this, then when we say async IO down here dot run, okay, everything will just execute every step and close. But if we want our process to keep waiting for other events, okay, to listen to events, okay, then we have to say shutdown.wait. Okay, then of course finally we do the cleanup process, which is stopping the notification consumer and then logging that notification worker has been stopped. So this is going to be a separate background job or process that is going to be started using one image. So using one image, we're going to start two processes, okay? One for HTTP and one for consuming events. Understand that and you'll be good. That's the main concept, so that we can scale them separately, okay? Scale HTTP calling separately, and then separate, okay, the consummation of events separately. Maybe I just invented the word. I don't know if consummation even exists in English. You'll forgive me. All right. So then in the main method here, we say async io.run, okay, to run this worker function. Okay, so async io.run is what creates that event or the loop. Then of course, we do the usual Python thing. If name is not equals to main, may not equal, but equal, okay, it is equal. If name is equals to main, then we call our main method. Yeah, it almost made me to bite my tongue. Crazy. All right. Sometimes when you're doing something and you're trying to chase time, you can end up rushing because I see my time is moving, but I'll complete this before I leave. All right, now let's move on. So I hope you've understood what this worker file or Python module is responsible for. It is simply responsible for starting a background job, okay, not a background job, but a process, okay, or a container for consuming events. These events will be created or fired by the API container. That is why you see I left the Kafka producer to be started from the API container. And there are ways to improve this, okay? But you'll understand it step by step. All right. Now, of course, when you look at worker.py, you see it calling other functions, okay? Like start notification consumer, stop notification consumer. If you go to them, okay, you see they're in this new module called runtime.py, okay, which is in the consumers. Okay, so consumers are where we register the consumers for Kafka, okay? But it's all basic stuff, okay? If I show you from the beginning, we import a single IO, okay? Then we import a number of consumers, okay? A consumer for processing booking notifications, payment notifications, ticket notifications, process user notifications, okay? We import a number of constants like the Kafka group ID, Kafka topics. We then import the gene and an event consumer from backend.utils.consumers. Then we have default notification handlers, okay? For user events, okay, we use the process user notifications function. For booking events, we use the process booking notifications. For payment events, we use process payment notifications. For ticket events, we use process ticket notifications. They are all the same, okay? They do the same logic, okay? Actually, I will not go into each of these functions because I touched them way back in the playlist, okay? So those of you who missed that, you can check. But those of you who have been following along, I'm sure you're very perfect with this. So on line 17, we create an event consumer, okay, and give the group ID, which is the Kafka group ID. Okay, if you go to the value of this, okay, it simply says notification service group. Simply creating a group of events, okay, of service events, okay, as simple as that. Then on line 20, it's a function to register the notification handlers, okay. So it says for every topic, okay, and handler in notification handler.items. Remember, this is a dictionary, so you can get the key and value. Okay, we see the consumer dot register handler. We simply register them here. Okay, after that, we can now say start notification consumer. This function simply takes in a loop which is of type async io.abstract event loop and a consumer which is an event consumer or can be none. Then we say if the consumer, okay, if the consumer is not none, give it to us. Otherwise, we use the notification consumer, which is this one here. As simple as that. Okay, this is just a fail safe to make sure that we always have a consumer. Okay, then after that, we simply register that consumer using the register notification handlers function, which is this function here on line 20. After that, we say that consumer started. We start it and attach it to the main async IO loop. Okay, then the opposite is true. We have a function called stop notification consumer, which simply takes a consumer, okay, of type event consumer or can be none. By default, it's none. And this function returns none or is void. Then we simply do a fail check here to have an active consumer. To say that if we have a consumer, if the consumer is not none that has been passed to this function, okay, then we use it. Otherwise, it will mean that we are using this one here on line 17, okay, right here. That's what the else part of this function does. And then we simply stop it. So line 34 simply ensures that we have a active consumer to stop. Okay, it ensures that we get the correct consumer to stop. Line 28 also ensures that we have the correct consumer to start. Very simple. Okay, so this is a very, very good first step. And I think these are all the changes. So we have consumers, runtime.py here. We have in the utils, in the dependencies, I removed everything that dealt with those consumers, okay? Because it's not, when you think about consuming events, it has nothing to do with HTTP, okay? It cannot be an HTTP dependency, okay? So I removed them from this dependencies.py file, which I think is a good thing, okay? Then, yeah, I think that is it. So I'm going step by step just to make sure that you understand how I'm approaching the Kubernetes stuff, okay? And yeah, it will all make sense, and you will appreciate where I'm going step by step. In fact, it even helps to do so, okay? Because number one, it solidifies your understanding of the code base, and it avoids doing things like writing one prompt, okay, and telling AI convert this project into Kubernetes stuff, and you end up getting lost and breaking things and having to go back in time to undo lots of stuff. So I just want to keep it simple like this and approach it step by step. So I hope this was valuable for you. I will end it here. If anybody has a question, you can ask right now for those who are watching right now. I know many people watch after the streams, but sometimes they prefer having live streams so that people can give comments, feedback, and ask live questions. So yeah, the road to deploying this on Kubernetes. I hope you enjoy it, and yeah, see you in the next video. See you in the next live stream, whatever it will be. Bye for now. Thank you for joining.